Welcome everyone for the Azure Jump for Oracle Database Learning. Today is day three. We have had a lot of discussions on the basic database concepts. We have discussed about the licensing. We have discussed about the database versions, version history, evolution of the Oracle from version 2 to 23 AI, and we also discussed about the editions, Oracle database editions, standard edition, enterprise edition, and express editions. So those are all very basic understandings that we can get on the Oracle to begin with. But today, what we are going to discuss is very important topic that you will have to memorize and clearly understand each and every component of the Oracle database architecture. Okay, so today we are going to talk and understand more about the Oracle database architecture. Yeah, are you are you all ready for this Oracle database architecture? So I will slowly go on this architecture part. Okay, so today we will understand the terminologies and basic architecture. Okay, so how the Oracle database architecture looks, and what are the different components terminologies we'll have in the Oracle database. Okay. Okay, so this is how, like, your Oracle database server uh, distinguished. So Oracle database servers comprises with three main components. One is memory, second one is CPU, the third one is disk or storage. Okay, these are the three main components for your Oracle database. So all three components together on a database server, we call it as along with the Oracle software, right? So we call that as a Oracle database server. Okay, so right, right, SQL querying. So selecting DQL querying, right? Selecting a table, uh, inserting, updating the table, right? Deleting a table. So you all do, or developers do those activities, right? Sometimes we also, for practicing purpose, we do all those, querying side. So sometimes you do a query to the database, like, I'll just quickly open my note. Okay, so just a minute. Okay, you query select. Oh, sorry. Query select star from EMP. Just an example. Okay, so this query, uh, you will get an output in a milliseconds from the database. Okay, so what is the content the employee table is having from the database? So when you fire this query, you'll get this output, in just, in a milliseconds, right, from the database. But what takes to process this query inside the database, and how it, you know uh, get back to you with the output? So what kind of internal process will happen within the Oracle database when you fire this query? So that is very important, right? We need to understand that. We need to internalize those topics before we, go further on learning more topics on the Oracle database administration. So that is where we start. Like, Oracle database architecture is the point where we start and internalize all the concepts, how a database functions internally. So those are internals I'll be talking today. So how each and every component behaves and responds to the processes, and gives back to the user the particular output what he requested for. Okay. right? So Oracle database architecture, I talked about, right? It has three main components. Okay, one is memory, two CPU, which means process, background processes. Okay, and the third component is storage or disk. Okay, so these are the main components, three main components in Oracle, right? Oracle database architecture. So we'll discuss about each and every component here. Okay, okay. So the first one is memory. Memory. Okay, so this memory is divided into two subcomponents again. Okay, one is SGA, the second one is PGA. Okay, so the memory architecture is divided again, uh, two components. One is SGA, one is PGA. Okay, just remember these terminologies. So we will further discuss on them deeply, and in complete internals I will be discussing. So what SGA means, what PGA means. So basically SGA stands for uh, system global area. Okay, and PGA stands for program global area. Okay, so these are two memory components. Okay, so one is system global area, the second one is program global area. Okay, so will talk about system global area in depth in coming slides. Okay, and program global area as well in depth in the coming slides. So just memorize these SGA and PGA. Okay, so we'll give you guys a proper understanding what SGA does and what is the purpose of it, and what is PGA functioning, and what is the purpose of the PGA in the Oracle database. Okay, all right. Um, I'll I'll go to the I'll go ahead another one. Okay. Um, let's talk about SGA. Okay, system global area. Okay, so this concept I will talk to you guys. So basically SGA is having a multiple components within it. Has a multiple components. Okay, so I will discuss about each component. Okay, so mainly we will divide it into three categories again. Okay, so we'll prioritize and tell you guys, like, what are all the important components that you need to understand better. Okay, so the first one is, sorry, the first one is, okay, shared pool. The first one is shared pool. Okay. Again, this shared pool is divided into two components. The first component is library cache. Library cache. The second component is data dictionary cache. Okay. Data dictionary cache. Okay. So shared pool is one of the very important memory architecture within SGA. Okay. So it has library cache and data dictionary cache. And then other component within SGA we have is database buffer cache. Okay. So we have a database buffer cache. Okay. So then we have another couple more components within SGA. Those are like Java pool, stream pool, large pool, okay, and redo buffer cache. I will write them. Java pool and large pool, and then stream pool, and then redo log buffer cache. Okay. So based on their chunks, I have divided like this. So majority part database buffer cache will be taking. Okay. And then shared pool, Java pool, small amount of the memory it will take. Large pool, another small amount of memory it will take. And the stream pool. So stream pool is an optional, and Java pool is also like, when you have a Java related running on your Oracle database, then it will be used. Then otherwise, it is also optional. And redo log buffer cache. Okay. So these are the basic main components of a SGA, your memory basically. Okay. And and then we will also have you know uh, after the SGA, uh, this is about the memory, right? So within memory, okay, I will write here memory. Okay. SGA and PGA. So a small component PGA also will be there within the memory. Okay. All right. Where is it? Okay. This entire stuff is memory component. Okay. So SGA and PGA, memory architecture. It is entirely a memory architecture. So now, then after memory, we have CPU, background processes, right? So what are those background processes? Let us look at them as well. So the background processes. So we have uh, SMON, we have SMON, and we have PMON. All right. Uh, okay. SMON, process monitor, PMON. Okay. And we also have DB writer. Okay. Just bear with me. Database writer. Okay. And also checkpoint, also arc writer, archive log writer, and log writer also. Okay. Checkpoint, CKPT, and log writer. Okay. And then arc writer. Okay. So these are the background processes. Background processes. These processes will be created when you install a database software in your server. Okay. So whenever you install a database software, but along with the database softwares, these services will also be installed on your machine. Okay. So I will talk specifically. I'll spend enough time on these background processors also separately. I will go whatever I have written over here. These you know uh, components, I will be discussing individually on each and every components and spend more time on them to give you guys enough understanding on each and every component and their purpose and their function also in the Oracle database. Okay. So you have written the uh, right, and then we will have a storage. Okay. Storage. Storage basically your okay. All right. So so whenever you create a database, okay, when you say, once you install the database software and create an instance, I'll talk about the instance also. So create database. When you say create database, that create create database, db1. Okay, for example, I'm telling you, so it will immediately create three files. Okay, the first file is control file. Okay, the first file is control file. The second file is crd, redo file, redo log file. Okay, the third one is data file. Okay, so whenever you create a database, immediately these three files will be created. Okay, crd. Okay, so crd, together we call as a database. Okay, so storage, either it can be a disk or any storage. Okay, whatever the storage you have in your server, and that storage, whenever you create a database, it will create three files: control files, redo log files, and data files. Data files. Just understand the terminologies only here. So I will go in depth on each and every topic coming slides. Okay, so you have a memory. Memory will have a internal structures, and internal structures, within internal structures, shared pool. Shared pool again will have a two components: library cache and data dictionary cache, and then database buffer cache, and Java pool, large pool, stream pool, and redo log buffer cache, and then PGA. PGA is also part of the memory. Okay, so PGA will be very small amount of memory, it will be there. Okay, but the maximum memory will be allocated to the SGA only. Okay, because SGA will have a multiple components that processes the database. Okay, so right, so till now you're understanding, right, the basic components here. Okay, so together these two, okay, background processes and SGA and PGA, okay, we call it as instance. Okay, so we call it as instance or system identifier, SID. Okay, so SID is nothing but instance only. Okay, SID is nothing but instance only, system identifier. Okay, so whenever you start a database, right, so whenever you start a database, okay, start a database. Okay, so how you will start? Either you will, to start up the database in Oracle, you need to set up the environments. Okay, so how you set up environments? Either manually or Aura env. Okay, Aura environment variable. So there it will be asking you an SID. Okay, so there it will ask you SID. Okay, nothing but your instance, so which is nothing but SGA plus background processes, BG process. Okay, SID is nothing but instance. Instance is combination of SGA and background processes. Okay, in the Oracle, where you can see the SID information. Okay, where you can see SID information. So you can see SID information in /etc/aura or a tab. Okay, this is the file. You can see the SID information. Okay, if you have a multiple instances running on your machine or multiple databases running on a machine, you can get that information, how many databases or how many instances are running on your particular server, you will get here. Okay, so again we'll come back to the instance. So in Oracle, one database will have one instance. So one database will have one instance. You're getting my point? So one database will have one instance. Okay, at least one instance. Okay, if it is a standalone server, a database must have one instance. You may ask, like, without an instance, can I start the database or work on the database? Absolutely no. You cannot open the database without an instance. An instance or database instance is the combination of memory and processes that are part of a running, like, when you are when you have installed the database software, those processes will be created. All the background processes, pmon, smon, dbwriter, checkpoint, logwriter, archiver, all these processes will be created. And also set of files. So I talked about the storage files. Right now there are other types of files also, like will be there, like uh, parameter file, listener file. Those are files I will be talking. Those are all, like, configuration files for the Oracle database, where you can configure your SGA, PGA, database buffer cache, redo log buffer cache. All these parameters can be configured with that parameter file, SP file we call it as. Okay. Sometimes, often, like, we call this database instance as a entire running database. But it is important to understand the distinction between the instance and the database. Okay. So instance is completely different. Instance is nothing but SGA and your background processes. Okay. And database is your actual data, where your storage is there. Okay, your control file, redo log file, data file, CRD files. Okay, we call it as CRD files, to just to easily memorize what are the database files we have in the Oracle database, which are control file, redo log file, and data files. Okay. So in this Oracle database, this instance can access only one database. So which means one database, one instance, one database. It's like a one to one. Okay. Uh, when you start an instance, okay, so once you start the instance, then only you can start the database. Okay, then only you can open the database. So here the instance will work like the mediator between the user, the end user, okay, and the database. When I say database, control file, redo log file, data files. Okay, so in the Oracle database is where the actual data is stored in your storage. Okay, your storage or disk is the database. Okay, I'm again reiterating, an instance can mount only one database at a single point in time. Okay, it is a only one to one. One instance can open one database. Okay, and there's another case. Okay, so this case I'm talking about the standalone. The other case, now I will be talking about the multiple database instances and one database. So that will happen in the cluster environment. So basically like a real application cluster. So there you will have a multiple instances and a multiple hosts, but you will have only single database. So those servers, multiple servers will access that single database in a rack environment. So many instances on servers can access a central database to enable the high availability and scalability. Okay, so that concept is for the high availability, okay, and scalability also. When you want to have a more resources, when you want to have a high availability, so rack is the option. So rack will have a resource sharing as well. Okay, if you have a multiple systems in the cluster, so those resources also will be shared uh, as a, you can scale that. If your environment is growing bigger and larger for the enterprise, you can add this uh, additional nodes, so which will add the resources as well to your database. So that with that you will get a scalability, at the same time high availability. So if one node goes down, so the other node will be available. But with this, end user will not be knowing, like, which instance he connects to and access the database. It will be like, normal only how he connect to the standalone. It will be the same for him. Okay, he won't see any difference while he connect to the database. Which instance he connects, he don't have to worry about. It serves the purpose, and it gets back to him with the query response. Whatever the query he triggered in the database, he will get the response to it. He don't have to worry about, like, which instance I have to connect. Doesn't matter. So in the rack environment, there are some concept like, scan listener, etc. So the end user doesn't know, like, which instance he connect to. He connect to the database, that's all. So instances, if they have a multiple instances, they work on, their own functions and, concepts to get the data retrieval. And again, finally, without instance, database can exist, because I said database is only the files where data stored, but that database cannot be used. You cannot access the database. Okay, without instance you can have control file, redo log file, data files, but we, you cannot use them, you cannot access those files. Those are all not readable files, not human readable files. Only Oracle database software, when the software is installed and an instance created, all this memory and background processes will do the maintenance and accessing of those databases and reading the data files and retrieving the information and keep the information in the memory, process the information, and that information will be given back to the end user, okay, client, basically. Okay, so that could be an application, that could be a, simply a third party tool like, SQL developer, or just a SQL utility, SQL plus utility, or anything, any tool or application, is a client for the database. So database, Oracle database works on the client server architecture. So for any questions, any questions from anyone?
Actually, no.
Am I clear to you people? This is very important topic. Please, raise your voice if you have any questions. So we will have some interactive discussions as well. So far, what I have discussed is very basic stuff. Okay, it's a beginning point to, familiarize yourself with these, components. But each component will have its own purpose and functionality in the Oracle database. I will discuss that also. But at a basic architecture, I explained you so far. Okay, so basic architecture, you can see here the architecture of the Oracle database, so how it looks like. Okay, I just, simplified it and, drawn that diagrams, and explain to you people, but the architecture looks like this. I have separated those important components and explained you so till now, but actual database architecture looks like this. See, if you see here, instance, so that instance is combination of SGA, PGA, and your background process. Okay, I only talked about pmon, smon, db writer, checkpoint, log writer, archive. And there are other process also runs. So some are optional, some are mandatory. I will deeply discuss all of those optional and mandatory processes that you need to know as a dba. Again, I'm reiterating, database instance is a combination of SGA, PGA, and background processes. Okay, so three main parts you need to understand: system global area, program global area, and background processes. That's nothing but instance. So in Oracle, when you open an instance, when you mount an instance, you can only, sorry, when you open an instance, when you start an instance, you can only mount one database. It's only one-to-one relation, one database, one instance in this standalone server. Whereas rack, you can have a multiple instances for one single centralized database.
Okay, means we can have one database per instance.
Yeah, in standalone, one database
Hmm.
by one instance.
Okay, in enterprise we can have multiple
No,
database
no, no,
in the same.
no, no.
Uh,
Standalone, which means
okay,
standalone is different and standard is different. Okay,
okay,
standalone server
mm,
means it will be one instance, one database. Okay,
okay,
cluster
mm,
is different. Standalone cluster, I'm talking. Okay, cluster is nothing but rack. There you will have multiple instances, but only one database. Okay,
okay. Mm,
so this is the basic understanding concept. But whereas the other architecture, multi-tenant architecture, is there, right? So there you can have a multiple pluggable databases under a single container database. So, like in SQL Server, we can have under the instance multiple databases, right? Similarly, we can have
yeah.
that kind of mechanism in the Oracle multi-tenant architecture. Okay,
Okay, that is from
12C
12C, right?
onwards, yeah, 12C
Yeah.
onwards that is available. But till 19C, this concept, like what I'm talking, the normal database concept, it is okay. From 21C onwards, there is no concept called normal database. Okay, but the architecture, concepts, functions, everything will be same, but only
Mm,
minor changes will be there at the architecture side. Okay, the within the component, like within the architecture, the component functionality, everything will be same, but architecture side, so they will be having a multi-tenant architecture. Okay, where you will have a one container database. Under the container database, you will have a multiple pluggable databases. Okay, so it is difficult, right? One database, one instance, you know to solve that problem, they come up with this multi-tenant architecture. So now you can have from 21C
Okay.
onwards, it is mandatory to have a container database and pluggable database creation only. By default, you will get PDBs.
okay,
Container databases in the sense in the Oracle. So what it means like there will we need to create a container and then we need to install inside it, or means
No, no, no,
how means like
not
we
like a
need to
Docker.
do multiple installation.
it's not like a Docker container or something. Okay, it's within the Oracle itself. So there's a architecture for that container database architecture, and we will create while we are installing the database software. So we will get an option to create the container database. Okay, so that will be a master database. So under that container database, you will have a pluggable database, smaller or medium, large databases, whatever. Like you can create a pluggable databases. So I will talk about that architecture as well. Once we familiarize the basic architecture, okay, the basic Oracle architecture, we will talk about the multi-tenant architecture as well. So what is the difference between the normal database architecture and the multi-tenant architecture? The concepts like there will be pluggable databases, there will be a container database, and there will be a seeds. I will talk about all of them. Just park for now on that. Okay, so don't get confused. Let's first understand properly on the normal database concept. Okay, again, I'm telling you, all the components functionality will be remain same on the other container database or multi-tenant database architecture also. Okay.
So right now, this architecture is basically, it's, I can understand, it is like a top, means like first is the memory part, right? The SG and the
Mm,
PGA, and so all
yes.
over the memory part, and the background process also comes under the memory part, right? The
No,
processor, it's will be
process
in the memory.
not in the memory. Memory is SGA and PGA only. Background processes runs in your CPU, right? Not in memory. If it sits in
Mhm.
memory, it will interact with memory. Okay.
Yeah, yeah. Oh, sorry. Yeah, process. Yeah,
Process, right?
yeah,
And
yeah.
from the SGA,
Sorry,
PGA,
I'm.
some memory will be allocated to your processes also. Each process to run the process on your CPU, it will have to also be allocated with some memory also to process the data and keep the data results, everything, right? So each background process will be allocated with certain amount of memory from the SGA or from your memory itself. Okay, your server memory. I'm talking. Okay. So I will further simplify this slide. This is looks little clumsy, right? So I'll simplify this little more. Let me take you guys to the next slide. Oh, yeah, you can see it. This is a bit simplified, you know, diagram than the previous one. Okay, so you can see when a client application, you can see this point, right? Client application or a client, you know, request for uh, database, and he wanted to query something from the database. Okay, select star from EMP. He wanted data to retrieve and see the information in his client machine. Okay, so this client can be application or client tools or anything like an application server, any side, the connection established from the client only. Okay, when the client when the client is requesting something, immediately a user process will be created. Okay, so I will talk about user process, server process. Okay, so just understand the terminologies. When a client requests for something, immediately a user process will be created. So that user process will communicate with the server process. This server process resides within your Oracle database. Okay, so this server process resides your Oracle database. So then this server process interacts with your instance. Okay, so this server process interacts with your instance. So while this server process is interacting with your instance, this server process also be allocated with some private memory. Okay, that is a PGA, program global area. Okay, so this program global area will be allocated to the server process to have some memory like session details, and who's connecting, which user is connecting, what is his information. All this will be stored here in this PGA. Okay, okay, once the session is ended, the PGA again will be cleared. Okay, server process also will be
Every
created.
section will be having their own PGA, right? Means
Yeah, every server process will have its own PGA. If you are having another client, okay, Oracle database is a multi-user, database. You can connect multiple, users at a single time. Okay, concurrency also will be there, so multiple users can be connected at the same time. Okay, so when you have another connection, okay, that time I will show you. That time again, same. Okay, sorry. Again, so same, another user process will be created when it requests for the database information, and then another server process will be initiated in the database server, and another PGA will be allocated to it. So, for example, this user session is ended. Okay, immediately this PGA will be disallocated. Okay, when the session is active, PG will be there. When the session is ended, the PG will be deallocated. Getting? Okay. So when a
just
user,
more add on it
sorry,
means like so this is it will be a share means this memory is getting from which or we have some component where we define some memories for this PGA means
yes,
because
yes,
as you said SG is a memory part and the PGA also is a memory part, right?
yes, yes, it will be allocated. Your,
So
yeah, I will talk about when you have a server will also have a memory, right? So within that memory, some part of the memory will be allocated to your database. Okay. uh, I think SQL background people can understand. We have a SQL instance, right? We will allocate min and max memory. We will allocate, right? You're getting right, and I'm not comparing, but I'm just trying to give you a correlation. Okay, don't compare apple to apple here. Okay, just a correlate. Okay, just correlate. So similarly here also a memory will be allocated. Okay, so you can allocate the memory, SGA memory, PGA memory, and within SGA database buffer cache, how much memory you wanted to allocate. All this I will discuss. Okay, just hold on for now, like let's focus on basic terminologies, because it's a very lengthy
okay,
concept. If we get confused at any point, like it'll be really you know difficult to understand the future concepts. Okay, let's focus now in the present. Okay, I will definitely explain you each and every component with the internals, full details. Okay. Yeah, where are we? So client request for the data, and immediately a user process is created. Then once the user process is created, that user process interacts with the server process. This user process will be initiated from the client mission only. Okay, so this user process will be initiated from the client mission, and that interacts with the server process. Okay, so before it is interacting with the server process, there is one more concept called listener. Okay, so one more file will come into the picture, that is nothing but a listener. So listener will decides, okay, whether this client is legitimate to connect to the server or not. Okay, whether this client is having an access or not to the server. Okay, so listener will have an information of database server, IP, host name, database ID, and SID, your instance ID. All that information will be available. At the client, the same is configured, then it will allow that connection, okay, to the server process. Okay, so listener will exist both client and server, both the sides it will be existed. Okay, so that will be validating whether the client is legitimate to connect to the database or not. Once that decides it is legitimate to connect, then the server process begins. And for the server process, a PGA will be allocated a private program global area, a private memory to hold the session information, session memory, everything. And then that server process interacts with the interacts with the instance. Okay, interacts with the memory. Okay, so here memory, all components we have, right? Shared pool, database buffer cache, redo log buffer cache, large pool, Java pool, streams pool, all of them is there, right? No, so that server process interacts with the SGA. Okay, and then based on the case, okay, so these writers like DB writer, process monitor, these uh, uh, background process continuously runs on the Oracle database server. Okay, and each case, based on the case, case to case, this functionality and existence of this background processor will come into the picture. Okay, then this instance will interact with the database, your database. This is your database: data files, read log files, control files, and archive log files. Okay, this is your database. Okay, so archive log, why I have not mentioned in the previous slide archive log files, it is like an optional one. So when you when you enable the archive log mode in the Oracle database, then only these archive log files will be generated. Okay, if you are not enabling archive log mode, these won't be generated. Okay, we will learn what is archive log mode and what are these archive log files contains in the future sessions. Just I'm letting you know why I have written over here as part of the database files. Okay, so this instance only, okay, will interact with the database. No other component will interact with the database files. Without an instance, these database files cannot be accessed or read also. So the actual data will resides in this data files. Okay, so the actual right information that you store on a table, okay, that will be stored in your data files. And redo log files will have changes. Okay, control file will have important information of your database. It's like a metadata. Okay, so where my data file stored, where my redo log file stores, where my archive log file stores. So what is the scn, uh, all this information will be available over here. Okay, and archive log files, all the changes that happen to the database will be captured and stored in these archive log files. The SQL Server transaction logs will be there, right? Similarly, in Oracle archive log files. Questions? Are you guys able to understand? So, for any difficulties, are you there with me?
Yeah, we're here.
Yes.
Yeah,
Now,
could
no
you please
questions.
repeat from how the server processes interact with the other components?
Sure. Yeah, I will talk about that, in a flow. Okay, right now we will memorize the terminologies. I will
Mhm.
explain
Okay.
that concept, each and every step by step process. So how
Okay.
it
Okay.
interacts
Yeah.
with the SGA components, which component will do the process of the query, will do the temporarily stores the data that retrieved from the data files and gives back to the server process. Okay.
Okay. Yeah.
Yeah. Server process is bidirectional. It is responsible for your user request. Okay, so it's like in a hotel. When you go to a hotel, you will uh, when you sit on a table, you will get a server to your table, right? Okay, to serve you what is required, what is the order from you, and getting the order from the kitchen, and getting that order prepared by the chef, what kind of ingredients required, what kind of dish you want, everything mm, you know will taken care by the server process only. It's like a server in a hotel, and in a simple analogy, I would say. User process, it's you visiting the restaurant. Okay, then uh, immediately when you visit a restaurant and sitting on a table, so you will be seeing a waiter or a server coming to you, right? Asking uh, what is your order and what do you want from the table. Okay, so then once you give the order, he will take to the kitchen. So then from the kitchen, there are different people will be there, right? Not chef, um, and master chef and cutting master. Different people will be there, right? Similarly in SEA, we will have a different things, and background process also. Okay, so to do your job. Okay, so to do your job, there are some background processes. So those will be completing your job and now giving you back the right order what you have ordered there. Okay, once that order is received by the server, he will give back to the user. You getting?
Yes. Yeah.
Yeah. So let's see, a little bit high level architecture it is again. One more architecture, the same. I'm just putting you another slide. So this we have already discussed. I don't want to discuss again anything, because in the uh, notepad we have discussed the same thing. Okay, so this is another slide, just for your reference. I have kept it in the slides. Okay, so client application will connect to the server process will be allocated with the PGA. Then it will be interacting with the SGA, and also the background processes also. Okay, so those background processes will do what is necessary uh, for the server process, and get what a job that server processes gets gives to the server, and give back those inputs and results back to the server process will take them back to the client. Okay, okay, so till this point, any questions?
Uh, just want to means like the flow, if we understand means what the thing like the whenever the user is a means have a request and server process to the verification using the listener, it will
Yes.
go to the means fetch the data means these are two things. So right now what we are focusing here means like if the user wants a data, so then it will look into the shared pool like data dictionary cache, right? If they want the data, and then it will go to the
I will,
means if
Tanish.
data is not present, so it
Uh, Sorry to stop you there. I will
okay,
explain.
okay, sorry.
I will explain the flow, entire flow. Okay. So how Oracle server, uh, Oracle database server behaves for a select query, step by step. Okay. So when it uses the library cache, when it do the parsing, uh, all like data dictionary. what is data dictionary is having, what is the shared SQL, what is the PL/SQL procedures and packages in the library cache. So database buffer cache, what is database buffer cache, dirty reads, what are the dirty reads. So all I will explain. Okay, for now today, uh, it's a part one. Just we are trying to understand these components at a high level, just terminologies. Okay, and terminologies. Tomorrow if I go and explain in depth, right, you should not be surprised. I'm just hearing this terminology for the first time, should not be feeling like that. Okay, that's why I started explaining these terminologies. We will have a flow. I wanted to have a created one slide where it can graphically represent you all step by step process and explanation also, so that way you can better understand the whole architecture. If I say now my architecture is, and I can conclude the architecture part, then that's not the real architecture discussion or the explanation. So each component, like I will have one slide. For database buffer cache, I will have one slide to discuss about it. So redo buffer cache, I will have one slide to discuss about it. Data dictionary cache, I will have one slide to discuss about it. And library cache also, and background process, each background process will have one slide to discuss about it. And database files also, how data is written in your server from table spaces, like it will have a physical and logical uh, component, like distinguishing. So physical, you can see right now data files, redo log files, control log files, archive log files are physical, you can see them. But in database there are logical structures also there to effectively write your data in a server, in a storage. Okay, so those are like table spaces, segments, extents, blocks, all of them. I will discuss each and every topic with each and one slide. Okay, so you will get proper understanding of the internals. Okay, I'm guaranteeing you guys that you will get a complete understanding of internals of the architecture. First day of the architecture, I don't want to overwhelm you with all the explanations. For now, let's stick the basic architecture, stick with basic architecture and the terminologies. Got it? Tomorrow begin with the we'll dig in each and every component in the SGA, in the PGA, in the background process, data files, etc. Clear? Any questions? Okay, I take this silence as no for now from you. Anyways, we'll catch up tomorrow. Tomorrow is very, very important. We are going to go internals. So each and every component I'll be, spending some time and discussing with you people. So let's, catch up again and looking forward to meet you all tomorrow again. All right. Thank you, everyone. Thanks for joining today. Have a great rest of
Thank
the
you.
day.
Thank you.